Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, Matt.
Hey, I'm John.
And, we're kind of back now. We're here all together. Last week, we were at SOUTHTEC 2023 in Greenville, South Carolina. You heard us do our day one wrap up, and we didn't do a day 2 or day 3. These are only 3-day shows, and so we kind of leave the
to get to everything.
Usually, your first day is your gut punch day, where you kind of see, kind of what you think you want to see, and you kind of get your bearings behind you about, what is going to be the next 2 days, and pretty much how much your life is going to be a very interesting moment for the next.
Am I going to make it to every booth?
Right. Or are my feet going to survive? Or are my legs going to survive? Or why is my arm going numb now that I'm carrying this bag?
You can print those.
Yeah. You would print those shoes.
It gets you done.
But, we're back now, and now we want to do a wrap-up. So what we're going to do is we're going to go over the entire show. Front to back, back to front. And kind of cover what is or was SOUTHTEC 2023. They are not going to have a SOUTHTEC 2024. There will be a SOUTHTEC 2025. So if you guys can make it to that, love to see you. Because most likely we may be there.
I think there's also a WestTech and a few other conventions similar.
I think it's a EastTech.
Who'sTech? They're
South
down in
Tech,
Houston.
WestTech.
Yeah. So I mean, there's other opportunities, but yeah.
HughesTech was the other one.
Yeah.
But yeah, SOUTHTEC will be in 2 years. So,
yeah.
I wanted to kind of, I guess, take it from here, and since I wasn't there, which I missed out, but it is what it is. I want to see these machines in action, anyways. I have YouTube. I can Google these things, anyways. Yeah.
Google Foo.
One of these days, we'll get you guys with the augmented goggles, so I can just sit with you while I'm at work, have a little screen following you. But
then you got to hang around when we're doing happy hour and make everybody else jealous.
Yeah, there you go. But yeah, no. So I just wanted to take this and kind of say, hey, ask you guys some questions about what you thought, maybe some categories. I mean, you definitely guys have told me some companies that have kind of stuck in your brain a little bit based on what they're doing, but. I guess I want to ask a few questions on that side. I mean, we did the same thing last time when we went to Rapid.
Mm-hmm.
So I guess my first thing is I could start out with is, what did you see at the convention that kind of caught your eye? It could be a product, it could be a booth, it could be an exhibit, it could be a speaker who just kind of commanded the stage and talked about something that that needs to be said. But I mean, what do you guys think? You can go first, Nick, if you want, or Ed.
It doesn't matter. I would say the biggest thing that I saw. I've already been exposed to subtractive manufacturing. We've actually talked about some of the limitations of additive manufacturing from a prosumer point of view. But for me, one of the neat things that I saw there was like when we was looking at some of the CAM software, where they were doing some things with the CAM software, where it was pretty intuitive to do some of the things, and it was also able to do some simulation.
With just the camera?
Well, the CAM, so you got CAM software.
Okay.
So basically you can take models and put them into this software, and then that software could do a simulation, or could do you can do some analysis on the motion, for example, if it was a robot, or the motion if it was a 3, 4, or 5 axis CNC machine.
Yeah, like the CAD cam guys.
Yeah. I mean, then the other thing, that I would say that was fairly impressive is we stayed with the flow guys and saw the water jet technology. Now that was pretty neat.
Yeah.
That's a rabbit hole.
Some of the things that they were doing, as far as how they were able to cut through material based on the height that they could raise the head. So it's basically a XYZ coordinate machine, but they were able to cut like tungsten, not tungsten, titanium.
Okay.
They were able to cut tool steel, aluminum, so Inconel. So they was able to cut some of a lot of different materials. The only thing they said they have a problem with from a material standpoint is tempered glass. and because the way tempered glass is made, what happens is if you cut it at the wrong angle, then it shatters.
Yeah.
So that's one of the limitations of the machine, but that's probably limitations of a lot of technology. But I would say that was probably a few of the things, and then the cobots was probably the other thing that I thought was pretty impressive.
Yeah. Some things that just caught your eye. What about you, Nick?
I've got a few. And the thing is, it gets kind of funny. But if you know my background and what I work on a daily basis, you understand. The first one would have to be the 3D scan guys. The guys out there running the 3D scanners. I think the software those guys and the cameras those guys are running are absolutely amazing. The company that we were talking to they're a sub company to Zeiss. They make a camera you can mount on the end of a cobot, and that cobot can do all your scanning for you.
Yep.
And it pipes it to a PC, which doesn't really require too much back to it, and it pipes it as an STL file.
Yep.
And it can do all of your measurements and stuff like that, your deformation measurements, and kind of do all that fun stuff. Yes, the CAD CAM guys, especially the guy Kyle from CAD CAM, just the energy coming off that guy when we first talking to him is insane. That's the guy who showed us they'll run through their software and he can grab on an end mill, and the end mill is not going to burn him. Because the fact he takes all of is destructive heating, or destructive cooling and stuff like that. So it actually puts all of the heat into the chips, instead of into the part itself, and not into the hot end. The same thing we saw with the Greenwise guys that were cutting into titanium.
And that was basically like 80% of your heat was being dissipated through the waste.
Yeah.
10% was in the tube, and 10% was in the material.
And it's
impressive.
It's gonna sound kind of funny, but the ERP guys.
Mm-hmm.
We had a lot of conversations with a lot of ERP companies, and especially a lot of maintenance ERP companies that you buy their software, and they're out of Canada. I think is the big one that kind of caught my eye. Is for them is you buy the software when you buy your equipment, and you kind of work your way through the process, so it keeps your life cycle. And it's individually installed based on shop, and it's only for maintenance. It helps with your spare parts, it helps with your maintenance costs and stuff like that, and your rundowns. It does all your advanced analytic stuff based on your ERP. And then you have and then one of the companies we talked to does all the job codes. They print out all your job sheets, and whatnot. You did have staying in the ERP realm, you do have some MES guys out there floating around, but it's not like MES that we think about. It's completely different than everything else. So I'd probably say that those guys would be some of the ones that would catch my attention. Then there was the rabbit hole guys. Probably the rabbit hole would probably be Flow. Which is the FlowJet guys, like what Ed brought up. These guys, they went out of their way to sit there and talk to us, knowing that we looked at them like you got three eyes. I don't know what you're talking about today. Hate to break it to you. We don't know anything about this flow stuff. Please explain this to me like we're 2-year-olds.
Yeah.
The gentleman who takes care of, who is the manager, I can't remember his name. I have a card someplace. The gentleman who takes care of all of their like field service guys. He's the service manager for Flow. That dude is awesome. He took his time to sit down with it to really walk us through the process. I think their entire team was awesome. Everybody we talked to at Flow, those guys were great. Everybody loved them. They've been with them for a long time. And I'd say that's probably, if it wasn't getting into some of the other stuff, I guess we can say that's the newest invention stuff. But I'd say Flow was probably some of the ones that really kind of caught the attention, because it's something new. You're talking about Garnet going up Mach 3.
Yeah.
In a 5-axis.
It's kind of ridiculous speeds to cut. I mean, to be honest with you, that would catch my eye too. Like if you've got a big machine making some pretty precise cuts, like I want to see it do it. Show me.
Yeah.
So yeah.
The sound behind when Garnet hits Mach 3, it is absolutely insane.
So you actually hear it.
You hear it break the sound barrier.
Different. Yeah.
Oh wow.
You'll hear it break the sound barrier. And if you think about it,
a little thump from the machine.
It's not even a thump, because we got to think about it. The entire bed that it's sitting in is full of water, so the water is used to dissipate the power
Oh, you just
of
probably
that.
see the boom.
You hear it. I mean, you hear that garnet come out of that nozzle at Mach 3, and it's whistling.
Oh, okay, I see what you're saying.
Yeah,
And-
so they can do just water,
Yeah.
and you can tell the difference when they add the aggregate. Once they add the aggregate, then there's a difference in the sound.
Okay, that makes sense.
And when you hear that, because when it hits the water, it breaks it apart, so it kind of slows down. So we can't reuse the garnet. But if you keep it in the same spot, it will punch to the bottom of the tank and straight to your concrete. So there's always that problem. There's always the thought that you may have some do with a mop. Trying to clean up a couple gallons of water, but you can drain it and weld it back shut and it's done again. But it's
the biggest problem is cutting a hole in my machine.
right. But you're also talking at 5-axis nozzle at Mach 3, and you're making the turns at Mach 3.
Yeah.
And we're talking. One of the guys was saying they have, and this is why it kind of really caught my attention. They have a guy, one of their customers, who's taking I think it was a 4 foot by 4, I think it's 4x4 block, right? Or 4x2 block, I think it is. And they're of titanium, and cutting a bearing out of it with a water jet, flow jet.
And it's a workable bearing.
It's a workable bearing.
That's impressive.
And it's 2 feet by 4 feet. And it's cutting straight through that without even thinking about it. They said it's fun when you start hearing it cut in titanium because it's actually starting to spark.
I was going to say, at a certain point, you're going to catch a fire, right? Yeah.
But I'd say that's probably, my top couple.
Okay. Yeah, no, this is a long list, but that's fine. I mean, so those are things catching your eye, but you talked about it a little bit, the innovation of each one. I mean, you brought up a few things each, the flow jet cutting or garnet and water, or what is it called?
Water jet.
Water jet. So what other, if any, innovations did you guys see where not only is this like an invention of a brand new type of a process, or what other inventions did you see that's just wholeheartedly just going in a different direction than the rest, if that makes sense?
Ooh. I think me and Ed are probably going to be on the same page here. But we'll have to go, take a walk over to the Philips commercial booth. They're right up, to give you an idea where we're at, you walk to the booth form, you make a left, and they're right there. They have one of their NASCAR Cup cars there. And all the Haas machines, Philip Haas Racing, is a member of the Phillips. Stuart Haas Racing.
Okay.
Phillips is part of the Haas family of brands, or they work with them. They're integrators of the Haas family of brands of CNC machines. The one thing that we were looking at the regular machines, and they're working with cobots, and cobots. Okay, cool. Everybody's got a cobot this day. However, they said, "Hey, what do you think?" And we had a conversation with Sharon, who is the head of PR, and said, "Do you want to do a podcast with us?" And she said, "You need to go down and talk to our gentleman down at the additive side of the house." Well, first thing you're going to do is you're going to raise an eyebrow because you're at a subtractive manufacturing show and you're now talking about additive. And then we get down there and they start talking about hybrid technology, which is the incorporation of melt-IO, of wire feed welding to form your block inside of a CNC process, which will then be cut by traditional CNC methods. They were making wrenches on site the entire day.
Tiny wrenches?
No. Now you're talking like crescent wrenches here.
Okay.
With tool steel in the middle and stainless steel on the outside. And it was 100% welded, no need for sintering, nothing.
You're just giving those things away. I'll take one.
We didn't get lucky enough to get one,
yeah,
but hopefully if we talk to them, we'll get one.
They could make it, and they didn't have any post-processing.
No post-processing.
No, they actually machined
They're
it out.
doing the post-processing
They machined
for
it out,
you.
and the guy showed us the wrench. But the counterfeit on what he said is actually disruptive laser metal deposition technology. So it does use sintering to do the processing, but basically you can use single head or you can use dual head. So you can use one material or two material. You can also use a wire and a powder also. One of the biggest things is it's an open system. So you can actually purchase regular weld wire for whatever you're trying to process, so tool steel, or say if it's mild steel, or if it's Inconel. I think the limitation right now may be copper. They're still developing copper, but the titanium, you can also use these materials, and you can use titanium with other materials. So you can use it as a dual process. The other thing is it has 6 lasers in the head, and these lasers are about 200 watt, and basically that's part of what that's the magic behind the curtain. So that's the wizard in their system. But the thing is Phillips has been, working the additive side for a while. I think Mark Forge did some stuff with them also in the past. So this is something Phillips been working on for a while. So they not only they have 60 years of experience with CNC equipment from Haas, but they also now have made it a effort to bring additive and subtractive as a application. So depending on what the application is, I mean, we know what Melt IO can do. We've seen it. They also do some stuff with EOS too. So
our friends over at EOS we've talked to.
Yeah, so like it's not like they just stuck a head onto a CNC machine.
Yeah.
They actually integrated it. It's got some chillers and stuff involved. You can add a cobot if you want to offload the machine,
Right.
And it has a pretty good interface for Melt IO to do things. It's pretty intuitive. I think there are some signals that go back and forth between Melt IO and Haas.
Okay.
But for the most part, it's pretty much they can come in and integrate that system for you pretty easy.
Now, to add on to that, and this is one of our bigger topics that we talked about the entire show. I mean, it was the entire day, nights conversations as we had with this thing, especially at dinner. We kind of talked about it, but how we were just kind of, dumbstruck by, this technology and stuff like that kind of made you think that, okay, is this really what's going on? We had to go back and take a look at it twice. But the price point. The price point for that system is $250,000 for them to integrate that onto an existing, or roughly $250,000. Don't quote me on that. Get a quote from Phillips.
Yeah.
They'll be able to help you out. We'll put their link in the bottom of all this too. So you'll get a quote from them. But we were told it's about $250,000, roughly, ballpark range to get started into a single dimension CNC machine. Mind you can do 3, 4, 5 axis machines, mini mills, and all that stuff, along with this process. And the reason I bring that up is because, our friends over at Mark Forge, they have and they had it at the show, obviously, one of the metal 3D printers that we saw at...
Like a tabletop.
Yeah. That we saw at Rapid, where you'd print it, then send it through the sintering process, then bing, guess what, toaster's done. However, that process, those 3 machines right there is $200,000. If you already have a CNC machine there, you can incorporate the Melt IO process for $250,000. And now you're $50,000 more, yes, but the thing is your productivity goes, skyrocket. I'm not taking anything away from our friends at Mark Forge. If you need metal 3D printing and you don't have a CNC machine and you don't want to pay the price, go to the Mark Forge. It's a 100% safe system.
Yeah.
They know what they're doing. They've got that stuff down to a science.
Yeah, Mark Forge has a lot of stuff.
And they also can integrate that Melt IO onto a robot arm.
Yeah, that's what I was saying, because you mentioned it earlier. You can get it to where the part's finished, to get it to pick the part, put it in like a waiting area or a loading bay or something like that, so that it can start the next print.
Well, if you put the head on the robot, then the space that you have.
Oh, you're saying
you mount the Melt IO engine onto the end of the robot tooling for the end tooling.
Right.
Now that robot, whatever the the area its work envelope is well larger than a CNC table.
Mm-hmm.
And I don't have the limitations of a CNC far as the work envelope. I mean, think about SpaceX where they're printing rockets.
Mm-hmm.
It's kind of the same concept. 3D printing
SpaceX.
rockets.
Well, they're printing engines.
Well, I mean, still you're using a robot.
EOS machines too.
They are.
I think.
They are using EOS
Yeah,
machines.
but it's the same technology.
Yeah.
You're basically taking a robot, putting that technology on the end of the robot, and the robot is doing the work.
Which is funny because they're using Haas CNC machines.
Yeah. That is funny.
So I'm just saying, like, it's a smaller scale,
Mm-hmm.
but the concept has already been proven here terrestrially and out in space. Far as
that makes sense.
the structure and the integrity of the thing that's being printed.
So you kind of bring up a good point too, because we were talking about just industry in general, but I'm thinking, how much is the space flight, space travel, getting to space, getting back from space, how much did that? I mean, I would say that we're getting close to some type of, if we're not already in one, a space race of who can get to where, who can get to these asteroids and figure this out. To me, I feel like there's always a scientific article where someone did some math on an asteroid that's going to hit us and they're trying to figure out something. Was there anything with space or like space habitat, like lunar modules or things like that? I know that we saw some stuff at Rapid.
There was a few of the like combustion chambers.
Right.
They're showing off combustion chambers.
Kind of like EOS had the air spike or
they didn't bring out that this time. Hate to say it, they also didn't bring out the basketball. I think we saw one basketball the entire time we were out
They had
there.
the little small one.
They had the baby basketball. They had the
but
full
it was
size.
the airless one.
Yeah.
Oh, nice.
They didn't bring out the full size one. They said it kind of grew legs.
Yeah, someone found it.
But the thing is they did. I think they made. I don't think they had an aero spike out there. I know they had a combustion chamber.
Right.
And a couple other things.
So mostly just engines.
Right. That some of these guys deal with. Some of these guys are dealing with the subtractive version of the engines themselves. And then with them, you guys got the guys partnering with the tooling guys. With bits and collets and all that stuff. Collets are a whole other big deal. I'm telling you.
Right.
Collets are insane.
So did you guys see? Was there an overwhelming focus of, let's say, the processes that companies are doing? I know some companies do. You just brought up Philips, who does printing, like standard printing similarly, or metal printing, and then they CNC and then make sure that everything's, if they add anything on, they can. What's the overall consensus? Is it 3D printers? Is it engravers? Is it CNC machines and things like that? Or is it machines that are using welding?
So
what was the most
I think it was a
density?
mixture.
Yeah.
I think as far as the additive side is still in its infancy far as the industry, hence the name hybrid, because that EOS was there, and yes, we had Maker Forge was there, but like the stuff they were doing, far as comparing that to the integration that Philips did, Philips was the only one that had one that was incorporating existing technology with additive manufacturing. The other guys were strictly, like Melt.io were concentrating on, hey, these are the machines that we have to do whatever. So they were basically still from, hey, here's our commercial version, industrial version, blah, blah, blah. So I don't think there has been enough innovation yet to say, hey, yeah, it's been a big push, because this is fairly new technology for this field. It's used in other fields. We could probably say it's probably used a lot in scientific, maybe developing new or complicated structures that can't be created by normal applications that exist. So some shapes we just can't do with a CNC machine. Or it's not practical.
Right.
So from that point of view, I don't think anything there was like that. And as far as from a space part, they probably did some stuff, because they did have, some things that they did with DOD. They did have some things that they did with aviation, but I suspect that they're not gonna, in that particular climate, they're not going to probably share everything that they're doing.
They had the combustion chambers.
Yeah, show the tips and tricks.
They had the combustion chambers sitting out there, so they did touch on it, and they'll have the conversations with you and kind of tell you who some of their customers are and people who they're working through. You know, a lot of times you see a lot of the guys. We noticed if you start talking about really wanting to get into how do we work with robotics to move forward in space race. I think you can turn your way toward the cobots. Yeah. The cobots they had that show, they showed that, hey, guess what? These things can, handle jobs autonomously. And some of the machines like Fanuc actually would take older machines and retrofit them to be automatic lathes, and then have a cobot reach and grab the part and put it over there.
They took a vertical mill and automated it.
Yeah. And so they would add it to the inspection station, and if it passed the inspection station, they dropped it onto the conveyor off away.
That makes sense. Quality gate.
So the thing is you can... The fun part is, if you walk through that show, you could take pieces and parts from every little bit, combine them into one production line, and you'd have maybe one human in the entire process. Down at the end, that would load the start, and they wouldn't touch it from there.
Last guy who's got his thumbs up, and he's like, I
you,
press the go.
You probably wouldn't have to have that.
Yeah, maybe not.
You probably, the one human would be the guy developing the problem or the solutions for the application that you're dealing with.
And
that's where they're going in the digital environment.
When you start talking about
I can see that
extraterrestrial, and we start going moon basing and lunar basing and stuff like that, and you start dealing with some of these machines that are doing the hybrid stuff, and you have cobots involved in that. Now you have entire workplaces that can be transported via Starship onto the lunar surface, and pretty much they run themselves.
Yeah, I mean,
in the grand scheme of things.
I think the problem now is power consumption.
Yeah, that is the biggest issue.
That right now, even if you use lunar anything, where it's like a lunar vehicle that's riding on the sand, or if they're going to use the helicopter or whatever. Like for example, India, I think in July, finished their launch to the southern hemisphere of the moon.
Yep, they
searching
landed
for water. And they had two low-tech.
Chandragandhi or something like that.
They did it manually. It was not autonomous.
Yeah.
It was actually driven manually, and it's a 3-second delay. And it was 2 times that it almost ended up in the crater. But the problem is because they made it cheaper, I think they did maybe a couple of million, whereas like when NASA does something, it's in the billions to launch. And they cut the cost, but the problem is the cost of cutting the cost, gave them some...
It's quality.
Well,
almost.
So you get 14 days on the moon, and that's the cycle, and after 14 days, the temperature changes. So when the temperature drops to a certain level, unfortunately, because they cut costs, the equipment that they sent up there couldn't take the cooling.
The drop. The
temperature drop. Like I said, the biggest thing is you have to either figure out how to do something with fuel. You have to find a fuel source there that you can convert into something electrical, or you have to figure out something on a nuclear, something nuclear.
Material science based. Or you're talking about
energy, because those things you're talking about consume energy. You have to have a way to power those things. Unless you can use the resources of wherever you're trying to go, then that's the limitation at this point. It's not the technology, it's just powering that technology.
No, that makes sense to me. I mean, to be honest with you, it's something that I was asking the question purely just to gauge the interest at SOUTHTEC of additive manufacturing. I mean, we went to Rapid, and that was the focus, was additive manufacturing. But it was like, I mean, it isn't always like I talk to people about 3D printing now, and it's not. It's more, they know more about it, but it's not. It's still not where we should be, and it's still not. It's a growing industry. So with that being said, I know this was you guys' first time there, but so if we had to say, was everything pretty much like drop-in ready for a lot of solutions, or were people offering full solutions, or were they just saying, buy my machine, it can make your part? Because how many presentations, how many demonstrations? I feel like everybody should probably had a demonstration, but What stood out?
Well, I'll say this: the thing, as far as like, it wasn't a bunch of pitches.
Yeah,
No.
there wasn't any.
It wasn't that way. It was like you just went to the booth and you talked to the people, and then you asked questions, and they gave you information.
Mm-hmm.
Now, when you start talking, like when we say, "Hey, did somebody have a solution?" The emphasis, I think, was not on big industrial plants.
Right.
The emphasis was on the guy that has a shop that's making parts.
Right.
If I can, hey, I don't have to get this block of material. I can build this up.
Mm-hmm.
I can reduce the cost because I'm not wasting the material.
Mm-hmm.
I'm only doing to near fit what the part is.
Mm-hmm.
So I'm only doing a few thou over what the part is, building up the material. Then I finish it up.
Right.
So you're saving the cost of the stock. So in the long run, you're on some. It could be, and then here's the other thing that they emphasized was that it can also be a solution for repairs. I have a part that's broken out in the field. I can have this piece of equipment make that part for me or fix that part.
Mm-hmm.
So this you pretty much answered the question before I could ask it. So I mean, that's pretty much what I was getting at. Is like, so what dilemmas that people see in the industry, like let's say we have a paint mix room, and there's a giant mixer in there, right? And this has to be commissioned to be created for this tooling, but you could really make it with one of these machines at these places here. Yeah. So like, honestly, most people are cutting that cost. So that's kind of what I was getting at, is like how ready to roll are a lot of these solutions. So if I broke my mixer in the paint shop and I wanted to get a new mixer, would I be able to make one with like one of these machines?
Tell them about the shaft.
And what's the biggest size that you guys saw printing wise?
I think you're talking probably at that show. Anything is probably inside 30 days. Installation to commissioning time.
Okay, yeah.
After you go through the whole selection process of what you want. Right. Once you go through the procurement side, which could take up to 6 months depending on what company you're at, or a year and a half if you're at some other companies. Twice as fast. Twice as slow.
That's why I whispered.
The value engineering out. Depending on how you look at things. But the fact is some of that stuff is like 30 days time install. And we're going to drop this machine off to you. We're going to power it on. We're going to show you how to use it. And guess what? You're on your own. Congratulations. Have fun.
Yeah.
Here's all your classes you can come and take with us.
Okay.
So a lot of the places had their own solutions and stuff like that.
That was going to be
for example, the flow jet shows up in two pieces and they put them together. They
Yep.
level them. Okay, now
and your floor.
Yeah, you got now. Most of the equipment that we saw at
has to be about 8 inches thick.
That we saw at SOUTHTEC, your floor has to be about 8 inches thick, reinforced with rebar.
Yeah.
Now,
just in case,
the flow jet machine.
That's the requirement.
Yeah, it's a requirement. The flow jet, for example, this kind of shows you kind of how creepy, how not creepy, I guess you could say anal these guys get. And how precise this machine has to be. What is it? 2
microns.
No, it was 2,000.
2,000ths
man.
of an inch off between front to back.
Yep. 2,000.
Precise.
Yeah.
Okay.
So but some of these things, you kind of walk through and you look at it, you're like, oh, that's awesome. But most of the time, you got a lot of guys who are system integrators, that are showing product and services and stuff like that, and stuff you can download almost immediately. Like some of the CAD CAM stuff, you're gonna be able to download it before you even left the show, and work with some of these guys and learn how to play with it. And they'll take the time out of their day. Most of them will take the time out of their day to show you what is going on. And all day long we had machines running, so you can't walk anywhere and not see a CNC machine flying around, doing something. They had one that was spinning a rim almost the entire time.
Cutting a rim.
Yeah, almost the entire time.
That probably had to take a while.
Then you have your laser guys, that kind of pop in there, that help with laser engraving and stuff like that. Your portable CO2 lasers.
Well, okay. Well, how about this then?
And which one were you talking about?
So that there's an application where the guy took a shaft that had been machined, and they took the technology and they built the gears, or the tooth, or the teeth, for the gears around the shaft. So you literally can machine the shaft, put this in one of these machines, it'll build it up,
finish the rest of it.
and you don't even have to finish it because they got it to near what it has to be based on your cam. If your cam data is correct, it's gonna be there. Now maybe you might have to do a little machining, but it's minimal.
Now I'm gonna throw something back at you real quick. When we talked about quick install equipment, we won't get into collets or anything like that right now. I think that'll be another question after we're done with this. So I guess you could say stock processing. Do you think that could be automated at all?
What do you mean stock processing?
Bandsaws.
So you're talking about I catalog my saws and stock processing.
No. Saw does it all in it now. Okay.
So you got to put it in context of what it is.
Okay.
Yeah.
So you have bandsaw.
Okay.
You have PLC.
Okay.
You have conveyor.
Okay.
Put all three of those together.
You got a little cell. You got a little station.
So basically, they got horizontal band saws that cut like big material.
Yeah.
They're cutting wafer thin.
You've seen them before. If you square tube and just don't know what they cut with.
Yeah, but it's a PLC that knows.
Yeah. So the PLC's doing the chop.
Yeah, and they're cutting them wafer thin.
Yeah.
Oh, okay. Kind of like how if you were going to Jersey Mike's, you're getting something and they're cutting those little thin pieces of the meat for your sandwich.
Pretty much.
Yeah, okay.
But this is stainless steel.
So yeah, this is stainless steel.
And it's probably about 3 inches round.
Yeah.
Wow. Now that makes sense. I mean, that's crazy though. That's intense, and to be able to get through that, that's got to be intense.
And it had like
it just drops down, cuts, opens back up again.
Well, I think
and then pushes it forward, drops down again.
A few of the CNC or bandsaw applications actually had a conveyor system that fed out the chips too. So they had a chip conveyor to feed it into a waste bin.
Oh, so there was because that was going to be one of the next questions. Eventually, I will get to sustainability, but I wanted to touch on something. I think we talked about it earlier. How many learning or training opportunities did you guys see at this place? Besides, of course, they've got the demonstrations, and you can glean what you can off of that demonstration. But like actually offering not just saying a certification or a degree plan, but like a training that is substantial to get you, I guess, approved to implement or approved to operate.
So I think that's where the SME and what was the other one?
Tooling U.
But it was another one, CIMT.
Yeah, CYMEE or EMEI.
Yeah.
Those guys are the cybersecurity guys.
And then I think it was also they had open OPC UA was there. So like they had organizations that were putting things together, but at the show per se, Fanic was probably the only one that was like concentrating on, hey, here's some training opportunities because they had that platform there. But the other ones were like live demonstrations, so I don't think it was really it wasn't really like we have a training. It's like Nick said, we have a training facility that you can go to learn these, but for the most part, I don't think they had the time to really, they could explain the technology, but they didn't give you any like, hey, this is what you do.
And they would talk to you about it a little bit, and stuff like that. They would bring up, hey, guess what? This is where you can go do your training at if you really want to go do this.
I know SME usually does like special
they do.
trainings. Yeah.
SME did I think they did a certification day the day before we showed up. They did all day long talks through the entire duration of the show. I think day one that we were there focused on personnel recruitment and retaining talent, and doing the announcement that we covered in the last YouTube video and kind of what we covered after day one. And then they kind of rolled through everything else. You got Tooling U, they were pushing. They had members there from Tooling U that kind of went through their process. And that's a SME sponsored and SME supported. It's their training wing. We had a good conversation with Bob, who's a CEO of SME, and he talked about how they have these moments with SME where you have 4,000 or 5,000 people in a Zoom call, listening to about, flow rates and feeds and speeds and, how do you do lean manufacturing and stuff like that.
Easy.
All that stuff that pops up.
Yeah.
But, it's kind of intermingled through the process. And then one of them, like what I was talking about, the Simi guys, they got a pretty cool little setup, I think. Once you think that the truck that they had out there that they used for their mobile training lab was absolutely awesome.
Yeah, that's a good idea. A mobile training lab makes sense. Bring the training to the people instead of trying to bring them to you. So that makes sense. I think that we talked about it earlier. The industry is growing, so you need to train the youth that are going into the workforce. Most likely, give them the opportunity. We can't force all of them to kind of want to do something in additive manufacturing, but it's if you don't know it's there, then you won't know that you like it, right? So you don't know what you don't know. So showing people this stuff or trying to teach them stuff. I've actually looked at Tooling U and some of those courses. It's pretty extensive with how many courses they have. So it's pretty impressive with how engaged and in how much training you can get off of that. So I would say just if you've got extra time, take a peek at it and try to kind of look at that. But I think that I guess my final, I don't really have many more questions, but my final one is I guess kind of one of our biggest ones. We've talked about sustainability continuously with consumables and stuff like that, even in a lot of our past episodes. Do you guys see any recyclers? I know it's hard for subtractive manufacturing and CNCing. You end up with a lot of dust and stuff like that, but you still end up with chips and things like that whenever you're cutting other things. Did you see anybody do anything special with that stuff?
There was a few recycled guys kind of mixed into the bunch, where they pretty much take your waste and convert it to recyclable material. It really just depends on the material, because some material can't be recycled.
That's right.
So if you're machining stainless steel, most of the time people will if you look at the machines, they have an auger bit that pushes it out through what they could sometimes nickname the poop chute and drop it into a 5-gallon bucket. So you could take that, the waste or the machine poo and take it to a recycling yard.
Yeah, jury's still out on that. I'm not a fan. I'm not okay with the phrasing.
It's one of those things where everybody's, if you look at it, it's like an auger and it just spits it out the back. The side of the machine.
I could see how we got to this conclusion.
But the thing is, you're filling up 5-gallon buckets. If you're machining a lot, you're filling up 5-gallon buckets. Yeah. The guys who are using flow jets, they have whole sheets, like cut out pieces that have whole sheets left over. That they can either reuse if they have space available. Yeah. Or they just recycle the entire sheet and they bring it to recycling yard and off it goes.
Okay, that makes sense.
I think that the Phillips gets rid of the waste because you're making it to almost dimensionally what it's supposed to be. So you reduce the amount of waste. So the way you generally would cut out a wrench, you would have a block of steel, and you would have to mill out that part.
Entire thing.
And all the stuff that's inside the cube goes away except for the part. With the technology of additive, subtractive, repeat, what you're doing is you're saying, make my part here and basically finish it to this dimension. So your waste goes down a lot. And your cost for material goes down. So it makes sense if you're running a shop where you're doing small jobs where you don't have to waste a bunch of material. And most of these small CNC shops, like I said, they're doing small jobs. They're not producing things at 60 of these a second or 60 of these a minute or so.
Yeah, that's fair. Makes sense.
Now, I'll throw this question at you. I want to, I don't know how much you kind of looked into, what about some of the stuff that's at that show, but collets.
Yeah, you're gonna have to explain that.
The big portion behind CNC is the collet, or a tool fixture, how a end mill or some sort of end mill mounts to the machine. So you have to put it through either a collet system, which is you put it through and you lock it into place with a screw down. and you pinch the tab shut to create the maximum amount of force to prevent rotational, dislodging.
Right.
Or you can heat them up so they expand, drop the drill bit in there, they let it cool, and friction.
Yeah, that's the only way. Yeah.
Then you have a bunch of other ones. There's different versions of the collets that they came up with. We saw a handful of different ones, ranging from not so expensive to you're gonna be broke. So how much technology do you think goes behind those collets?
Well, I'm gonna be honest with you because you just taught me something because I didn't know that had a word. I assumed just based off of looking at Prusa, XL or things like that switch tool heads in the middle, or just watching like in the body shop, just watching the tool heads change. It's not that much of an issue, but yeah, no, the connector piece that accepts either or is the coupler is very important to me. How much technology does that use? I mean, how can you get? What is it, magnets? Like how much are you really connecting it through? Are you connecting to a CAN bus system or something similar like that? Or minimizing wires? I think there's a lot of tech that you can use there. However, the more tech you use there, the bulkier it gets.
Right. And when you start looking at them, you'll notice they have tool changers where you have 5, 10, 15 tools. And the tools are your milling heads,
right,
located inside your collet, inside your mounting bracket. So they take that and slide it in the machine, lock it into place, twist, lock, and then mill out what you need.
It's pneumatic.
Right, it's pneumatic.
They use pneumatics to lock it in place.
Yeah.
And some of them I think they have probably the tap system like on your Voron.
And a lot of times it's exactly that. And a lot of times, but the funny part is the sealing of the end mill to the collet itself is extremely precise, because the problem is you get a little bit of wiggle, you get chatter. Now your part's destroyed. If you get a little bit of up and down, you're going to cut too deep in one section. They kind of showed that with one demonstration we were watching. You went out and back, and it was perfect height, and the bit dropped a little bit and cut deeper and deeper and deeper.
Oh no!
So, but here's the funny part: some of these machines you have to buy to set these things up. You slide the holder in, heat it up using electricity.
Yeah.
Drop the piece into the chuck, slide it over, cool it down, and then it seals up tight.
Yeah, so
that makes sense to me.
They use induction heating, so you take a coil, and the coil heats up the metal, and that's how they get it to expand, so you can drop. They had different systems. You can use the manual compression collets, or you can do like what Nick's talking about, where basically it's a more precise fit. And then it has to cool down. I think some of them was like 2 minutes. They had a cool down process of 2 minutes.
Okay.
And then they had the small little pieces where it looks kind of like a flower when it opens up. Yeah. You drop the drill bit, you drop the piece inside of it, then it locks into place as you tighten down the screw head.
That makes sense.
Kind of like your drill bit.
I mean, yeah, it's huge how it's very important that stays level too, and that's controllable. Not there's no deviation from where it should be.
Yeah, when you get into that type of stuff, when you look at it, it's absolutely nuts. And the fact is, the amount of technology that goes behind just the end mills themselves, because you're dealing with like cutting titanium.
Right.
You're auging out so much material, but you're trying not to overheat it. That be
because then you start warping it.
Right.
Yeah.
That should be cut. That should be sharpened to a certain bit. I think one of them, what was the biggest bit they had, was like 3 inches or something like that. Yeah. They were cutting with, and that was the size of the bit alone, the shank.
It was 3 inches.
Yeah.
That's crazy.
And you have servicing mills and stuff like that are like a good, like, looks like a pie plate. That's spinning at 12,000 RPMs, if not a little bit faster.
And it's shaving off of that.
It's shaving, but you're talking about shaving microns.
Yeah. Yeah, it's impressive. I mean, the precision is impressive, I will say. So
yeah, we had to ask the question a few times. Are you talking microns, or what are you talking about here? Because we had to make sure that our sense of measurement was correct.
Right. Because
sometimes we look at them and go, well, this is what do you mean by this? And we thought that we were off. Like, we can't be that far off. Yeah, we were way off.
Yeah.
I think when we were talking to Flo, I think that was the furthest off we've been in a while. How fast do you think this thing went? Well, it's fast. He goes, yeah, Mach 3. Oh, okay, a little faster than we thought.
Prove it.
And you're talking about the gantry weight is what, 3,000 pounds just for the gantry alone.
That's crazy.
And it's pretty much as high as it will go, is as deep as you'll cut.
Yeah. That's see, and machines like that are ones that, like, those are what kind of got us interested too in the first place. So like, if you see something like that, that's probably why someone's obsessed with this industry too.
Yeah, go watch Flow on YouTube. Yeah. It is absolutely amazing.
Check it out.
Go take a look at Philips additive hybrid.
Yeah.
On Facebook and a couple other things. Not Facebook, but on YouTube.
Mm-hmm.
A lot of stuff coming out of Haas. Titans of CNC is real big. They were real big out there working with these guys. Definitely go pay them, some respects.
Yeah.
Those they know what they're doing. So, any more further?
So I'm gonna be honest with you guys. You guys gave me a lot to think about. I'll probably come up with some questions a little bit later, but nothing comes to mind anymore. We talked sustainability. We talked about what wowed you. We talked about what was the kind of the density of additive, the subtractive. We talked about training. We talked about quite a few things, and all this kind of focuses on the fact that number one, we think it's cool, but number two, this is a growing industry. Its innovation is just never ending. This convention, I would say, isn't as big as Rapid, but that doesn't mean it's small by any means.
Oh no.
So at the end of the day, there's already thousands of people here interested in it. There was, I would say, thousands more at Rapid. There's going to be thousands more at any of the other industry conventions. So if you guys have a chance, I would say go out and check it. Honestly, this gives me a lot of the questions that I would have. What made you want to go? Stuff like that. I mean, we talked about what you thought was cool. That's what made you want to go. So I honestly don't have anything else. Unless you guys have any other companies or any other products you feel like you're like, I don't care. It doesn't fit in any of those fields. I need to talk about this thing.
There was definitely the Cobot guys out there, talking. They're getting into the fields. A lot of people that were doing a lot of artwork with these CNC machines.
Mm-hmm, mm-hmm.
So it's it's pretty cool to think about the fact that you got to deal with like their how they do things.
What do you mean by artwork? Like they're doing like some modern design on the front, like I'd see it at my college, where they have a statue that looks like a stick figure holding.
Well, more or less. Skulls.
Oh, I can see. So some sugar skulls. Okay,
yeah,
some sugar skulls, and that's metal.
Yeah, that's 100% metal.
That's impressive.
And then.
Yeah, so they're doing like full size actual models that are very smooth, precise. Like I don't see any layer lines, so that's something that to me is impressive.
That there, I don't know if that was additive. I think that was
subtractive.
That was subtractive.
That was a CNC machine.
So you're not going to see.
That's impressive.
Two markers.
Yeah, I would say that makes sense.
And they probably cleaned it up some too. And that's probably not that they're doing. They're just showing.
It was on there one of their machines.
They're showing
It's on the Herlock machines.
Capability,
the capabilities of the machine.
Yeah.
I don't think it's a real big market for making those type of things.
No, but it's out there.
Their machine is capable of that precision.
Right.
I think it's
show that.
Yeah,
they just want to show that. Most of it we said was subtractive, so it's mostly CNC machines.
5-axis machine also. So.
Yeah. And okay. I'll say this: what was good about the show also is the fact that we saw the kids there. Yeah. We had kids from surrounding high schools and stuff like that, STEM academies, that were at the show, that were getting face-to-face time with these guys, learning about the technology, really doing some training with these guys. Especially last day, it was 100% kids. And then, so I think for them, they got the biggest bang for the buck.
Yeah.
Be able to go to this thing. We still can't get over the Philips additive hybrid side of the house. I know we keep harping on them, but they're doing things with basic weld wire you can buy from Home Depot that most people would never think about. And they get 40 hours out of one 50-pound roll of weld wire.
Mm-hmm.
That's impressive.
And barrel,
it's like, I think they say you can get a lot more with you can actually use a barrel too.
Yeah.
By the barrel.
Yeah.
So like you powder the.
No, it's weld wire.
Weld wire.
The wire. Okay.
Like I don't know. Where we are, they use barrels instead of using the spools.
That makes sense.
Because the barrel, you can get more wire in a barrel than you can on a spool.
Okay. Yeah, that makes sense.
So, it's fun.
I mean, yeah, no. So all things considered, I mean, I appreciate you guys being able to go out there and kind of bring that experience to me. You know, I'm thankful that we're able to kind of do those things. So yeah, I mean, for me, this is just fuel for the fire, right? So it continues that curiosity and keeps it going. So I mean, I didn't have anything else.
Yeah, we'll send you down the rabbit hole of flow before we send you home. Get you started on some flow, so they'll drive you absolutely batshit, kind of batty.
I'm already crazy. It's too late.
Oh, this will just add to it. Physics and flow jets really kind of go hand in hand if you think about it, or just they don't, depending on how you want to look at things.
Yeah, it's tough. Physics is everything.
Yeah. Well, you start cutting steel with water and a little bit of granite.
Yeah, physics is everything. You see something that don't make sense, that's probably because the physics is like telling your brain that don't make sense.
Right. So, but I guess we'll call it there, guys. We appreciate it. We want to say thank you. Thank you for giving us the opportunity to go up and up to SOUTHTEC 23 this year. We are going to be having some of these companies on the podcast with us. Some of these guys you're going to be able to talk to directly. If you have any questions, please send them to us and we'll take care of it, or we'll get you in contact with the people that we have contacts for. We highly appreciate y'all listening to us. We hope we all learned something from it. I'll say this, since the last time we talked, we're at 5 people away from hitting, six people. 6 people away from hitting 2,000. Mm-hmm. So we're doing a really good job on that. We're really having some fun with it. You guys make it worth it. You make these trips worth it. You make, the investment and the time and energy worth it to go see these people and, kind of, spread our wings and, really get them interested and want to talk to you. So, I want to say thank you. Go check out, the blog. Go check out Printed Heritage. A couple other things we're working on. So, but, enough of me rambling. I want to say thank you. We'll talk to you soon. We'll turn it over to everybody else.
Yep. Just like I say, we appreciate the support. We like bringing you content. We still would like some input from you guys if it's something that you're interested in, or if it's technology that we haven't covered, because we always are interested in all types of technology. But other than that, appreciate it.
Yeah, once again, I say thanks to these guys for, kind of bringing this experience to us. I bet you there's still 1,000 questions that everyone can ask about, maybe even particular companies and things like that. So the company spotlights are coming, so stay tuned for that. Like Nick said, Printed Heritage, check out these things. We got lithophanes coming. There's a whole bunch of things that you guys can customize, and if you've got questions or have any issues with it, please let us know. But yeah, other than that, thanks again to these guys, and yeah, stay tuned, guys.
All right, y'all. Have a good one.
See you later.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.